Now that we have defined this definite integral and we have defined it and constructed it as the area of a region of a certain type, we can make some observations about it which will allow us to actually extend its use. What are the observations? Well, first of all, Riemann integrals can be extended to non-positive functions. Think about it. What did we define as the integral from a to b of f of x dx? We define that to be the limit as n goes to infinity of the sum from 1 to n of f of xi delta x. Now this is an algebraic definition, right? It does not really prevent us from computing that quantity even when the function is negative, or it's maybe sometimes positive or negative. However, we have to watch for what this definite integral then means in those situations. For instance, if I have a function like this, which is actually less than 0, it's all below the x-axis, I can still compute the limit as n goes to infinity of that sum, etc., etc. But now, of course, that sum, that limit will end up being negative because it's a sum of a whole bunch of things, each of which is negative. Okay? And so what I can conclude is in this case the area is going to be given not by the integral but by the negative of the integral. Okay. Similarly, if I have a function which is sometime below the x-axis, sometimes above the x-axis, so it has some area a1 which is below the x-axis, followed by another area a2 which is above the x-axis, followed another area a3 which is below the x-axis, then of course the positive regions will contribute positively, the negative regions will contribute negatively. Okay. So in that situation, the integral that we can construct, again, can still be constructed, but how are we going to interpret it? Well, it's going to be given by the positive regions, or the areas of the positive regions, minus the area of the negative regions, or the ones below the x-axis. So while of course there is a very strict connection between definite integrals and areas, that's how we define them, but remember that definite integrals don't always represent areas. Sometimes they represent the negative of an area, sometimes they represent some mixture of positive and negative areas. So we have to be very careful on how do we interpret it. Of course, later on we're going to also see some more applications of this concept of integrals to the computations of other quantities which are not areas, but again, we want to start from these basic things. Now, there are some other properties of Riemann integrals or definite integrals that are fairly basic, fairly intuitive, and that probably will never create any problems for you, and you saw them in high school. I'm not going to talk about them here. However, they are listed in your textbook. They're listed also in the written notes that you have, so I do encourage you to have a look at the other properties I'm not mentioning here and just remind yourself of what they are.